Chemistry and you are watching Chem Science.
In our earlier video, we have seen how surface area affects the rate of reaction, and in this video, we'll see how temperature affects the rate of reaction, and we'll also understand in terms of collision theory that how temperature affects the rate and what change will happen to the graph if the temperature is changed. So let's first revise few points about what is rate, that it's the measure of the speed of the reaction or how fast the reaction is, and we can calculate it by measuring how fast the products are formed or how fast the reactants are used up. The reaction of rate can be calculated by measuring how much of amount of the reactants are used up per unit time or the amount of products produced per unit time. So now let's see how temperature affects the rate of reaction, but before we start we need to understand what is activation energy. We have already seen that in our one of the earlier video about the rate and collision theory and the factors affecting rate, but let's revise this point here because that's required. Reactants must have at least some minimum amount of energy for the reaction to start. This amount of energy which is required, minimum amount of energy which is required for the reaction to start, that's called activation energy. Now if we draw a graph for such a plot where we draw an energy against the reaction pathway, then for an exothermic reaction the energy of the reactants will be higher and the energy of the products will be lower. But as we said, some amount of energy is needed to start the reaction. If we present the activation energy, then that will be higher than the energy of the reactants. So that has to be presented by a higher level of energy. So this amount of energy, the amount of energy difference here, this amount of energy is the activation energy, which we can call it as EA, abbreviation of activation energy. So the extra amount of energy required for the reactants to start is the activation energy, which can be found out by this difference. And the difference in the energy of the reactants and products is the delta H, that is the enthalpy change or the change in the energy during the reaction, total change in the energy during the reaction, which can be presented by delta H here. Now this amount of activation energy is discussed here. The reason being is that only the reactants which have this amount of energy, the energy equal to or greater than the activation energy, will only react. The other reactant particles which does not have this enough amount of activation energy will not react. So only few reactant particles will undergo reaction with equal or greater than the activation energy will undergo reaction. So what happens when we increase the temperature? Increasing the temperature will give energy to the reactant particles. So it increases the energy of the particles, energy of the reactants, means increasing the energy will increase the energy of the reactant particles. So as more particles have enough energy to overcome the barrier of the activation energy. Now you can say that earlier with a lower temperature or a temperature of room, only few reactant particles may have enough activation energy for the reaction to undergo. But now by increasing the temperature, more number of particles have reached this activation energy, and that's the reason that the speed of the particles increases as they have gained energy by increasing the temperature. The reactant particles have gained energy. So the speed of the movement of the reactant particles is going to increase. This will end up in more frequent collision among the reactant particles. This will end up in more number of successful collisions per unit time. Now what do we mean by the successful collisions? Successful collision means the collision among the reactant particles which end up forming the products. So increasing the temperature will increase the energy of the reactant particles. which will move with a higher speed, and so more frequent collisions, successful collisions per unit time will increase, and hence the rate of reaction increases. So increasing the temperature at the end is going to increase the rate of reaction. Now let's understand how does this affect a simple graph of a product where the concentration of the product is plotted against time. As we have seen earlier in our other video, that from such graph we can find out at any given point, suppose this point, we can find out the rate at this particular time by drawing a tangent at this point and find out the gradient, and then with the help of the formula we can find out the rate, the formula of change in the concentration of reactant particles upon the change in the time. And from such graph we can also find out that suppose at this particular time the graph has gone horizontal, so this is the time at which the reaction gets over. So the time at which the reaction gets over is T1, and this can be found out from such graph. Now if we increase the temperature, how is that going to affect this graph? The gradient of the graph will become more steeper. So increasing the temperature is going to make the graph more steeper, or it's going to increase the slope, and so you can see that the slope or the line of the graph goes higher, goes more steeper. And if you calculate the rate at such points by drawing a tangent, we will see that the rate is higher, and the reaction also ends up earlier at such a time. So you can see that the time at which the reaction gets over is also smaller. The T2 is smaller than T1. So the reaction gets over, finishes earlier. And this can be found out by plotting two different graphs of two different temperature of the same reaction. So this you can again conclude that increasing the temperature increases the rate of reaction, and in terms of collision theory, increasing the temperature increases the energy of the particles. This increases the successful collisions per unit time, and hence the rate increases.